Do you like uncertainty? Because if you are going to work with AI, you will be faced with layers upon layers of uncertainty. So, how can it still be made to work? This is the story of No Pressure, the AI native, tiny little website system. Long time ago, in a city far, far away, I used to work with a large British financial institution. I joined them in 2008, in the middle of the crisis, and I joined their global strategy team. It was a very interesting time to do strategy in financial services. In fact, that was the impetus to join. But why I'm bringing this up is that one important role of the team was to prepare the investor presentations. Now, if you worked in a highly regulated, stock market traded company, corporation, you would know that that's a very important piece of document. There are enormously complex rules, what you can, what you should, and when you cannot, and how to disclose things. So, the process of preparing an investor presentation was very well thought through, and we spent a lot of time on figuring out, firstly, what the strategy is and how we want to present it. And then Investor Day came. The presentation was out. And next day, we get the newspaper reports, right? That this and this financial services corporation had an investor day, and these were their main points, and this is what they thought, right? This is what they thought. Now, think about that for a moment. They had no idea what we thought, and they didn't get it right either. It was not what we thought. Why is this enormously relevant? Because when you are using any of the large LLMs today, they read the newspapers. They don't read what people thought. They don't read the internal documents. So, what the models get trained on is not the reality, it's the reflection of the reality in media or other places. So that's a scary starting point. Now, this is also true for program code, because what you get on the internet, GitHub and other places, is not the core essential code. I mean, there are enormously high quality stuff on GitHub and other places. I mean, just think about the Linux kernel, right? It's open source and it's out there. It's very high quality. Having said that, the patterns that work in the kernel might not be applicable to your application. And you get, say, Kubernetes, right? So brilliant, enormously powerful system management software, great. And then you have this long tail of all the other stuff. For example, No Pressure. I mean, So that's on the internet, and that's what the models get trained on. And now I'm talking about the publicly available models. That's what you get. You get what was published in the newspapers, not what actually happened. So the LLMs are not trained on the actual financial systems that are run by banks. It's not trained on Borg, which is inside Google. It's trained on Kubernetes, which is outside Google. And yes, I know, Borg is specific to the internal network architecture and everything of Google. But still, I mean, that's the original, right? And then Kubernetes is the generalized idea. And it's great, But there are a lot of other things where there is something like Borg and there is nothing on the outside. So what you get and I get is an LLM that was trained on the long tail. Now, this could be very different if you work in a large organization that can afford post-training on your own code base, right? It's enormously important, because then what happens is that those bad habits that were picked up by the LLM on the pre-training get, hopefully get realigned towards the standards, the code quality, the patterns that are relevant in your organization. So lucky you. That's one level of uncertainty. You get an LLM that was trained on not the crème de la crème, but whatever is out there. Some of it is crème de la crème and some of it is not. And in fact, there is going to be ever more generated code on the internet, which they pick up, and it's like a self-reinforcing loop of, it's kind of recycling rubbish in a way. Apologies. So that's an important consideration. That's a big uncertainty. And then if you are using the LLMs, they change. I've been using ChatGPT 5 very successfully from the summer 2025 when it came out. And then in the autumn, you got 5.1. And was it a disappointment? And then I was very thankful when 5.2 came out. If you are using AI, if you are using it every day, then you have to be mindful of this uncertainty, that you never know how and when the models will change. The second level of uncertainty is the system prompt. What is the system prompt? Very briefly. When you are interacting with an LLM, the LLM gets a package of data every time you ask something or continue the conversation. And it has many little parts, which basically represent the stages of the conversation or any attachments and so on. Now, the system prompt is what comes first, and it's inserted every time, and it's inserted by the system that you are using. So if you are talking to ChatGPT, OpenAI will have a system prompt. If you are using Gemini, then Google will have inserted a prompt. Now, it's one of the very strange things that I observed, and it cannot be explained by a change in model because it's the same model. Gemini, the 2.5 version, was a little bit of a loose cannon. I can't use it actually for code generation, but it was really good at code review, like really, really good, like went into the details, nuances, critical, and it found a lot of things. So one approach I used was to use Claude Code or Codex to generate code and then have Gemini review it. And it has a 1 million token context window. It has a big memory. You just saw it upload the whole thing, churn through it, and then give you a very good report on what might be wrong, what goes wrong, inconsistencies, duplications. Brilliant. It was very critical. I liked it a lot. And then what happened? It became really benign. It would start praising the code, how nicely structured it is. Now, it was still Gemini 2.5. So the only thing that changed between the use I had and the use I had was some sort of system prompt change, because otherwise the LLM should not have changed its behavior, right? So this is yet another level of uncertainty. So even if you fix the model, You have no option to control the system prompt. If the system provider changes it, it is what it is. There is an even more interesting question about the system prompts, because you might not be using directly Gemini CLI, for example. You might be using something like Windsurf or Cursor or any of these environments where these are just options to choose from, whichever LLM you want to use. Now, those systems will also have their own system prompts. What you can observe is that if you ask something in one of these systems or directly on the command line, you can have quite different results. And yes, every time you run the same command, you will get somewhat different results. But for example, the verbosity or the focus on what the LLM will focus on changes. And I can only surmise, because we usually don't have access to what the system prompts are, that they put in certain requirements or focuses into the system prompt between you and the LLM provider that influences how these behaviors change. And so in this case, you have the service provider system prompt, then the AI provider system prompt, and then the LLM. Right. So if you want uncertainty, here you go. Even more of it. And I would highlight one more thing about the system prompt. So this is not something that is visible anywhere, right? It's just there, and it's not a big document usually. And this can be changed by the service providers, AI providers, with no notice. It's not like deploying a new model. It can just be changed anytime. And that will have a significant influence of how systems behave, and that will also have an influence on how you prompt the system. So your ways of working might need to change. It was a massive change for me when I went from Gemini 2.5 being able to be really critical and thorough to being very positive about the code base. Now, I already mentioned this, but there is one more uncertainty, which is noise. That every time you ask something, it's not going to be the same output. Now, this is both good and bad, because it's good because sometimes AI gets it horribly wrong. And then the good news is that maybe you just retry and it gets it right. So you have to keep an eye on what your agents are doing. It's also bad in a sense that you no longer have this reliability. So our expectation of a machine is that it behaves the same way every time you do something with it, right? So if you turn on your oven and you set it to a temperature, your expectation is that it sets that temperature. Okay, so maybe this is a wrong example because ovens tend to be not very precise, but like a washing machine, that usually runs through the cycle. So it usually does the wash first and then the rinse and doesn't flip this over. But AI can definitely flip the two. And it would happily explain that it was a great idea. So we have to be really careful that results are not replicable. So that's uncertainty at an individual action level that you have to cope with. It's not over yet. There is also the context window. What is the context window? So the LLMs don't really have memory like a machine has in like your laptop, that there is a piece of hardware that the CPU, the processor, interacts with, and it makes changes and it remembers directly. Well, it kind of has, but the majority of what the LLM knows is encoded in a fixed neural network, that doesn't change. So the LLMs, once deployed, they don't learn. How they adapt to your requests is through the context window. That's the input. And the input will have a smartly structured history of what has happened so far in the discussion. Now, there is a whole very interesting discussion to have about this, but what I would like to highlight here is that this is all statistical, right? So the context window will have a lot of tokens in it, and it's not entirely clear what the LLM will pick up as important. Now, if you are continuing something on a piece of software, then this is usually less of an issue. Although this is how, for example, the LLM will forget to run the tests, right? So you have in your own setup an instruction that before you hand over code, run the tests, whatever works for that particular LLM. So you have that, but it still doesn't do it. Why? Because it didn't consider it through the stochastic statistical analysis that happens through that complex neural network, that it's actually not, I'm not going to pay attention to that. So what comes out is half-baked in a sense. But it's even worse when you have a change. And this is what drives LLMs crazy in my experience, that you have the old code, the old documentation, the new code, and the new documentation or requirements. And it's like, good luck with that. In many cases, it's just extremely hard to explain that that's what we are going to, right? So that's, in a sense, bad what we have in the past, and the good is the future state. So in terms of how you structure your process, how you manage what is in the, so to say, short-term memory of the LLM becomes incredibly important. And this is nefarious. There is one document somewhere in the depth of the code base, and it still refers to something that was 2-3 iterations earlier. And believe me, that's what the LLM will find, and then, go off on that tangent. And it's like, why did you do that? And it says, oh, because that document says so. It's like, oh, right. Okay. Can you please remove that from that document and do it over? Anyway, so uncertainty about what is in the context, what the LLM picks up from the totality of the available data. You can manage it to a certain extent, but as code bases grow, this becomes an important and challenging part. Now, one more thing, and then I finish, and it's access. It's very interesting to see how access to LLMs evolves over the day. So I'm in Scotland, and I start working before the US wakes up. And then you can see that, there is this little period where you give an instruction and then it's just mulling around, and then suddenly you start seeing the thinking. So that little period is where you are waiting for access to the big machine. And when the US wakes up and people start using it, then that grows. And then suddenly your workflow slows down. There is this matter to consider, that how reliable is the access? Yeah. And then, of course, okay, I'm not talking about when they have an outage, because that happens too, but fair enough, happens to the best of us. But this is just the amount of usage that is out there in the world, and then you start competing with that. Well, these are some of the uncertainties you face when you use AI every day in your work. Please do look at the other videos where I explain where No Pressure stands today and where it's going in terms of AI nativeness. No pressure it is. I am TeeAy, and please join me on the next video.